Hi, everybody. This is Mrs. Walker, and I'm going to explain Chapter 9.1 of the Holt book to you this morning in less than 5 minutes. Okay, so listen up. So, this is page 589 in the book, and this is about formulas for triangles and quadrilaterals like rectangles and parallelograms and trapezoids. This page right here talks about parallelograms and it talks about the formula. And if you look right there, there's the formula for a parallelogram. And I know you have seen that before. Okay, so there's the formula right here. This is using the formula. Now, in this parallelogram, you're not given that height, so you have to use Pythagorean's theorem right here to figure out what the height is in order to use the parallelogram formula. Okay, if you look right here, you use the parallelogram formula and then you substitute and get your answer. Now, this is good math right here. I like this. Write the formula, do the substitution, get your answer. Okay, let's look at the next page. On this page, they are using some really different kinds of things that you haven't seen to show sides of quadrilaterals. So here they're talking about the height of a rectangle. Okay, and all they do is they give you this little picture. I can't even see it, it's so small. Here, okay, oh, it's a 6. So they don't even draw the picture of this rectangle, and that's a shame, okay? Because basically what's happening, if you pretend this is the 5, is the 5 is here, and the area is the whole entire thing, and they're pushing these numbers into the formula in order to figure out what the height is. Okay, so see how they wrote the formula, did the substitution. Here they're factoring. Then they're dividing by 5. And then they're getting h as this weird looking thing. I know you think it's weird looking, okay? Now here's the perimeter of a rectangle in which the area is 12x feet, and this diagram actually belongs to this problem. Again, look, they use the formula. They substitute into the formula. They figure out the base that way. You're going to have some different kind of stuff to do. It's not your old area equals length times width anymore. Sorry. Okay. Then they get into triangles and trapezoids. And remember, basic triangles look like this. Trapezoids have the 2 parallel sides and the height. Okay. And they use this formula right here for the trapezoid, 1/2 base 1 plus base 2 times height. Normally, I would put the height right there. Okay, they do the substitution, they do the math. Voila, very easy. Okay. So the next page, again, talks about triangles. Now look, sometimes the height of the triangle is outside the triangle, and you might have to use Pythagorean's theorem to figure out parts that you need. Okay, if you're given the hypotenuse, here's a trapezoid right here. And notice again, formula, substitution, do the math. Down here are the formulas for the area of a rhombus and a kite. Now they have the same formula. This formula, area equals 1/2 diagonal 1 times diagonal 2. And they're just plugging the stuff in and solving. It's not hard. It just has extra letters. Okay, here's some more examples. And then they talk about a harder example. Okay, but I don't have time to go over that right now. Sorry. Bye. Bye. Bye.